Hey Paul, hey Joe, this is Daniel Lowery. Thank you guys for coming and watching my video. I'm going to go over my R-term project. So before beginning my project, I just kind of want to give some background and the motivations and what I'm aiming for to do with this project here in R. So this is going to be an application of linear algebra and multivariate calculus to the field of economic history. So in economic history, looking at population size in early modern Europe is difficult because there are a variety of estimates and none of them are very certain. So what myself and Professor Eric Cheney are trying to do is use number of scholars from a given city as a measurement of population. So the data is collected as follows. We scrape the Harvard Library system for scholars. These could be poets, these could be theologians, they could be scientists, mathematicians, etc. And we're going to find out when they lived and where they lived, preferably birth locations. We find these manually, then use a Python scraper on the cities to spit out longitude and latitudinal coordinates, and now I'm using a small subset of the data from England to look at population distribution. So the idea is we're going to look at cities, which is in the data. We're going to look at the distance between the cities and the capital London to look at the population distribution. Conversely, we can also think of this as the distribution of human capital, as these guys would have been noted scholars of one sort or the other. Either way, we're looking at it, either way you want to interpret it, we are looking at distributions. Okay, great. And also, this data set belongs to myself and Professor Cheney, so we ask that it is not used without our permission. Okay, great. Now let's begin. So the first step is to install packages. There's going to be a package called CAR and a package called RGL. Now since these are already on my computer, I'm not actually going to install these, but I will upload them from the library, and we will define some functions over here. Great. Now the next thing is to upload the data. We're going to use the read function to do that. Great. Now if we want to look at the data, I'll show you what the data looks like real quick. So we have the latitude of the birth over in this column, and the longitude over there. Centuries, which is the century they were active, and the number of hits, or number of scholars in that city. Goes down, we have 278 entries in this data set. Great. Now one thing that's important to note, if you run the script on your computer, you want to make sure that this file, rtermlocations.cv, is in the correct place. I have it under documents. If you have it under downloads or somewhere else, you want to change the code a little bit just to make sure that it actually uploads the data. Otherwise, you won't be able to do anything. Same thing that goes right here. The next thing, we're just going to define some variables: latitude, longitude, centuries, and scholars, and we're going to define that directly from the data. Now, the next thing we're going to do is we're going to define a function. It's going to be called chord. It's going to use multivariate calculus, and this is something that's inspired from, I believe, lecture 22, and it basically converts longitude and latitudes into vectors in R3. Cool. So now we have that function defined. Next thing we're going to do is convert London. London is going to be our anchor in this, so we're going to convert it. We'll call it L. All right. Great. Now that's converted. Now we're going to convert all of the other entries in our data set into that. And if we want to look at it, this is kind of what it looks like. As you see, we have it in rows. Great. Now the next thing we're going to do is we're going to scatter plot this in 3D, and that's using one of our packages. And this is what it looks like. It's kind of cool. We can rotate it around. As you see, it's kind of flat, so it's like, all right, obviously this is England. We're not moving around the globe too much, but this is not super informative. So over the process, we're going to see if we can get ourselves a better graph than this, although this is pretty nifty. All right, So now the next thing we're going to do is we're going to calculate the distance between London and the rest of the observations, and we're going to be doing this in kilometers. And this script right here is partially inspired by a script from, I think it's 1.29 from one of our problem sets, one of our R scripts. And this will spit it out into kilometers. Now over here, I have an alternative way of calculating the distance in XY coordinate, in XYZ coordinates. I have it commented. If you want to uncomment it and check it out, that's basically takes the square root of the difference of the squares. Okay. Now the next thing we're going to want to do is we want to get a weighted mean. So let's compute that real quick. All right, great. So what this weighted mean does is it weights the distances between the observations of London by the number of scholars. And that's really important because one city might have one scholar, and another city might have 4 or 5. So if we want to get the population distribution, we have to have the weights. And so that spits out a figure, and it happens to be, on the entire data set, it's 1.71. So for the entire time period, from 800 to 1400, that's the average distance from London. Now, that's cool, but we want to know how much it looks by century, right? We kind of want to see, okay, what is the trend in the distribution of England as England develops over time? Okay, so now we're going to do the same thing, but we're going to do it by century. All right, let's run that. Now we have a bar graph. Okay, so we see at the beginning it's rather high, and then it goes down, and then it kind of evens out over here. That's important to note in the beginning. We don't have a lot of observations, so it's really kind of hard to make too much of this. But it does seem that there is a sort of concentration of population, or you can think of it as human capital, to the city of London. Now, I do have more data, but it needs to be clean, so it'd be kind of interesting to see what happens once we extend this to 1500 and 1600. But for now, we can't do that. All right. Now let's see if we can get ourselves a better graph. All right, great. So now we're going to introduce some coefficients into the projection, and then what we're going to be doing is we're going to be projecting these R3 vectors from the unit sphere into a two-dimensional tangent plane. Because as cool as spheres are, it doesn't really do us a whole lot of good. So let's see if we can do that. Now we're going to run a for loop to plot the scholars in cities by century into separate graphs. All right. And we'll stop right here. All right. And then one more thing we have to do, we have to rotate the results around the origin so that north is facing up. Because right now, if we were to look at this, you'd kind of have England sitting on its side. And that's cool, but we want something a little bit better than that. All right, let's see what it looks like. Oh, wait. There we go. That's what we're looking for. Okay, cool. So let me just kind of maximize this. All right, great. So you have each of these are observations, and one more thing that we did in the script was we ended up plotting it where these circles are going to be proportional to the number of hits, right? So a smaller circle like this over here probably means there's just one scholar, but over here I believe there's 4. And so down here, as you see, as you move across time, you have more and more activity in the south. You have this big circle over here, and that's London. So there's a lot of hits over here, and then you have these other city centers. You probably have something like Oxford as a university city getting a lot of scholars, or other smaller metropolitan areas that are growing at the time. Okay. Now, one more thing we want to do is plot all of this together. Get all of our data on one graph. And we're going to do this, and I've added in this extra cool feature where we're plotting the centuries by color, and there'll be a legend that will show us that. And I did it sort of in a hot to cool, so it should make sense. not trying to save that right now. Okay. All right, cool. So you see that 800 is magenta, 900 is red, etc., all the way down to a dark blue. And you see these circles mean you have a lot of hits coming out of these cities. Now, one final thing we want to do is when we want to do some regression analysis. And we're going to be using distance from London to predict the population size as measured by the number of scholars from a given city, right? So over here, we're just going to define the matrix X as distance to London. We're going to add a constant in there, as is standard for doing regression technique. We're going to bind it, we're going to inverse it, we're going to define the matrix Y as the scholars, and we're just going to do basic regression analysis on this, and let's see what we get. All right, fantastic. So these are our coefficients. They're all negative, and we've also plotted the regression lines over here. Now, it's important to note you don't see 800, 900, or 1,000 on these, and that's simply because we don't have enough observations to really run a regression and get anything sensible. But what it does seem to say is that that the further away we get from London, that we're going to have fewer scholars on average. Okay. Now, I've enclosed a little bit more interpretation. You can look at it while you're going through the R script yourself. It says many things that I've already said, and then I've also put at the bottom a few things about the bonus points, pointing to various things that we've done. And I think that pretty much ends it for the script, I guess. I hope you guys have enjoyed it. I hope you've enjoyed the nifty graphics, especially the magenta. I really like that. All right, Paul, Joe, have a good one.